Welcome to Physics Made Easy channel. Today's topic is transistor as switch. Switch is a device which on or off the current in the circuit. This is the switch, note it down. This is the input voltage of the switch. Always try to understand the circuit, otherwise you will find it very tough to draw in the examination or very tough to conceptualize it while solving the problems. This is variable battery. When I was explaining you common base transistors, we were using their potential divider arrangements. Now this is the right way because it simplifies the circuit. Here is a cell and you just cross it with an arrow. It means we can change the voltage VBB, and this is battery. Remember it, this is battery, and this is biasing resistor RB. Biasing is done to avoid short circuiting. Biasing is also done to make up for the different transistor parameters. And now this is NPN transistor, as it is quite clear. Arrow is towards N, and it is in the emitter base junction, as I have already explained you. This is N, this is P, and this is again N. Now this is emitter base junction. It is to be forward biased. For forward biasing, this is emitter base junction. It is to be forward biased, and this is P type. This is P type. This has to be connected with positive of the battery. It is connected here. And this is to be connected with the negative of the battery here. This is emitter, base, and collector. This is RB is the base biasing resistance. This is VBE, base to emitter voltage. This is input voltage VI. And here we have got two currents. This is base current IB, and this is base current IC. Now we know this, that always remember this formula. In many of the problems you will have to use this formula. And even if you have to make quick calculation, you can put IE is approximately equal to IC, because IB is in microampere, base current is in microampere. This is 1000 times stronger, the base current. This is also 1000 times stronger, the base current. The contribution of this base current is very small. So even if you put IE approximately equal to IC, then it is not altogether unimaginable assumption or approximation. Now this is VBE is base to emitter voltage, and on this side we have got VCE. This is output battery. Now understand the difference between output battery. This is output battery, and there is a voltage drop across this resistance. There is a voltage drop across this resistance, and now we measure the output voltage across these two terminals, which is VCE. Here output voltage is measured. Here output voltage is measured. And now IE is the emitter current. Base current flows in this direction and IC flows in this direction. Now he has applied Kirchoff's law in this circuit, in the first circuit. In the input circuit he has applied Kirchoff's law. So according to Kirchoff's law, if we loop in this direction, like this, if we loop like this, here VB is minus, it is negative, and then we are in the direction of current, RB/IB is positive, and VB, base to emitter voltage, is again positive. So This becomes the equation, and this is the final equation for VBB. Actually, we don't need this equation. Now what is important is, now we apply Kirchoff's law in this looping in this way. So if we loop like this, first we have got battery minus VCC for battery, and then we are traveling in the direction of the current. This is ICRC, and then we have got this next voltage, which is VCE. So we get this equation. These two equations I will again explain here. This is very important, and I will give more importance to this equation, and we loop in this direction. First negative of battery minus VCC, and then we are traveling in the direction of the current ICRC, and then we are getting into VCE, which is collector to emitter voltage, and we can just write it as VCE, and sum of all these voltages is 0. It means VCE is equal to VCC minus ICRC. This is very important equation, which I shall be referring again and again. And here I want to draw the correlation. Now as the input rises, output will rise. Output will rise means IC will rise. If IC will rise, then VCE will fall, because IC subtracts IC multiplied by resistance RC is a factor which is subtracted from the battery voltage. As the current IC increases, the subtraction factor ICRC increases, which means VCE decreases. Now we have to take this into consideration. Now let us VC is the output voltage. These two equations, this equation is input equation. This equation is input equation, and this is the output equation. I have reservation with this input equation. This is wrongly written. VI is basically VB. So here there is a mistake. It should be, to my mind, this is battery voltage. VI is input voltage here. VI is input voltage. So this is not that important. So this equation, if we just assume it from here, VBB, battery voltage, this is battery voltage, we take it as VI. We took battery voltage as VI, nothing wrong here. We have just taken battery voltage as input voltage here, VI, nothing wrong. And then I will proceed towards this. We know that up to some certain value of input voltage, when input is less than cutoff, which is 0.6 volt of SI, in that case IB is equal to 0 and IC is equal to 0, IE is equal to 0. If IC is equal to 0, in that particular case, then V output is CC. Again listen. There is a cutoff voltage. I will write VI less than V cut off. I will write full in feet. Implies IB is equal to 0. Input current is 0. It means output current is also 0. Now if I use this equation, VO is equal to VCC minus ICRC. In this equation, VO is equal to VCC. Remember this thing. In the next part, active state. Active state is when IC is not equal to 0. So active state means input voltage is less than V cutoff. Just remember this. I will V cutoff voltage and less than V saturation voltage. SV means saturation voltage. VCOV means cutoff voltage. Input voltage lies between cutoff voltage and saturation voltage. In this case, as IC rises, VO will decrease. And the next part, and this state is called active state. And now we will understand it more correctly from this diagram. This is cutoff region. In this region, VI in this region, VI is less than V cut off voltage. I will be writing again. V less than V cut off, CO cut, O for off and V for voltage. Input voltage is less than cutoff voltage. In this case, VO is just equal to VCC. It means this is the value of basically VCC. And now, as the current starts flowing, we are familiar with this equation minus ICRC. We are familiar with this equation. Since this minus ICRC. Here. Now, in this case, as IC increases, as VO increases, now simple. If VI increases, this implies IC increases. Upward arrow represents increases. And this implies from the above relation, VO takes a downward trend like this. And this region is the active region. Active region is over which we operate the transistor. This is cutoff region, this is active region, and now this is the saturation region. Saturation region is what? Is when this is VI this is the saturation voltage. VI is larger than V. S stand for saturation and V stand for voltage. VSV. Now this is VSV. This is VSV. VI is more than VSV and this is V cutoff voltage. VCOV. This is VCOV, this is V cutoff voltage, this is V saturation voltage. This part is active region, written right on the top. This part is active region. And this part is saturation region. VI is greater than saturation voltage. This is saturation voltage, this is cutoff voltage. Along x-axis we have taken VI, that is input voltage. Saturation state, variation of VO with VI found to decrease towards zero but never becomes zero. In this situation, collector current IC becomes maximum and transistor is in saturation state. Now we have drawn a table to sum up the things. This is a table which sums up the things. VI low less than 0.6 volt, VO is very high, IC is 0, state is switched off. VI high greater than 1, VO is low, IC maximum, and this is switched on state. Moderate means lying between 0.6 volt and 1 volt. VO is moderate, IC is moderate, and this is active stage. So Vi less than zero point 0.6 switched off state. Vi greater than 1 volt, this is switched on, and moderate is active state. And next we have got concept of transistor as an amplifier. Amplifier amplifies voltage. It may amplify current. It may amplify power. It is used for increasing voltage, current, and power of alternating form. This is the input signal. This is the block signal of amplifier. This is power amplifier. Power added to the input signal comes from the battery, and this is the output signal. This is the basic concept of amplifier, and this is also a very important topic from your examination or need point of view, and I shall be covering it in my next lecture. Thank you very much.